Reaction kinetics, or rate of reaction, or speed of reaction, basically is a topic that is very much important for an industrial chemist, because in industries they need to maximize the speed of reaction, optimize the rate of reaction. Okay, so the reactions are going at a nicer pace, so less of the fuel consumption, less of the time taken, less of the labor used, and more products formed, and more of the shipment in the market. To reach market in prompt time or readily, you provide goods to the market. It means your chemists are working fine, they are efficient, production department is operating at an optimum rate, because your reaction or mode of reaction or the reaction you have chosen or the mechanism you have chosen, it means they are perfect. So when we say rate of reaction, it means we are talking about reaction kinetics. So this chapter basically will deal with how to find rate of reaction, what basically the rate of reaction means, how to measure the rate of reactions, what are different methods used, and then this chapter will deal the factors that affect the speed of a reaction. And when we know the factors, each and every factor has its own importance, and we need to look after it, and we need to find the best way to improve that factor. So together, collective approaches, the reaction rate is maximum, and your industry or your production department is facing no hurdles in providing the markets goods in the market in time. So basically this is an industrial chemistry topic, and at this level, GCO levels or IGCSE level, we need to know the basics that what the reaction rate is. When we say reaction rate, it means it is amount of reactant used in time taken. Amount of reactant used and how much time is taken. I mean, there is one way to find out. You can find out how much the reactant is used and how much the time has passed. So after obtaining a certain data, you can make a table. What was the time basically, and how much is the mass used. And once that table is completed, you have the stopwatch and you have to measure the time, and you can measure the mass. You will find out that you can find out how much the time has passed and how much the mass has left behind. So that table, and then you draw a graph. And look at the graph. Mass of the reactants on the y-axis and time on the x-axis. Of course, mass of the reactant with the passage of time will decrease. And decrease in mass of time with the decrease in mass with the time basically tells us about the rate of reaction. Okay, if the decrease is faster, it means your gradient is highly steeper. It can be like this even. And if decrease is slower, your gradient is not that steeper. So the steepness of the gradient can also tell us about how much is the rate of reaction, speed of the reaction. If somebody asks you to point out that the other reaction you have done is very fast, then show it on the graph. It means your gradient should be much more steeper. Okay, so this is one way you can find out amount of reactant used and the time taken. You've started with the reactant, they were having certain mass, and then you have the time noted. You can find out with time intervals that how the reactants are decreasing, how they are being used up. Okay, then we can find out the rate, how much amount of product is formed in a certain time. Okay, how much mass of the products, or how much the volume of the product if the gas is involved mostly, and the time taken. And of course the mass of the product again on the y-axis and time at the x-axis. You'll find out initially when the time is 0, the mass should have been 0, no products formed. But as the time passes along, you'll find out that products are increasing, and you are finding out the mass of the products formed, and at a certain point you will find out there is no more change. You can look at the graph and you find out it is much steeper in the beginning, and then slowing down here, and almost stopped here. So it has stopped almost here. Okay, same here, when it becomes flattened totally, it means the reaction has stopped. So we can find out the average rate by dividing the average mass with time, or average mass of the product with the time. We can find out the average rate, or even at some level we can find out the rate at any moment by drawing a tangent there. Okay, for GCE A levels normally we draw the tangents, so we can find out the pinpoint rate of reaction at that particular moment. However, at this level normally you'll find out the rate of reaction in average circumstances, like how much is the mass and how much is the time. Like if the total time for completion is 4 minutes, and how much the reaction has used up, how much actually the rate of the reaction is at the average rate of the reaction when the half time is used, you can look at the time axis and you can look at the mass. Okay, you can find out how much the mass of the product is formed. Like if the total mass of the product is suppose 100, and they ask you to when the half of the reaction was over, you can find out how much the mass actually, how much the time is there when the mass was 50. Okay, so it means we can find average rate at different intervals. So rate of reaction basically can be calculated by finding mass of reactant used with time taken, mass of the products with time taken. Either option you can use, depend on what sort of the reaction it is. In most cases when the gases are involved, then this method is fine. You can find out how much gas in a certain amount of time. Some reactions are very slow, dead slow. You cannot find their rate, like rusting. Rust takes so many days. Photosynthesis. You cannot stand close to a plant and wait for the photosynthesis to occur and you can take a fruit home. That will take too much of time. So almost not possible finding the rate. Some reactions are extremely fast, like explosive reactions or fires, jungle fires and other. The rate of reaction is meaningless there. But in most cases, in industries, we find the rate of the reaction depending on how much actually the time has passed when the reactants were there, or how much the time has passed when the certain products are obtained. So rate of reaction is important for industrial chemists to find the pace, progress of the reactions, to find out that how much is the amount of products obtained with a certain amount of time basically when they are passed. Okay, so they can meet the requirements of the market.